So you just came out with ArkType 2.0, and the big headline feature of that is it's 100 times faster. So how did you accomplish that large jump in performance?
Yeah, okay. Well, this is definitely gets a little bit in the weeds, but so there's this like just in time optimization that V8 will do if it's able to process code based on like certain constant references and things. So essentially, if you think about writing code, like if uh if type of data equals string, like or type of data equals number, and that's just like a function that you wrote or something like that. Let's say you run that 1,000 times, like V8 and in general, like any JavaScript engine to varying extents is going to be very, very good at making that extremely fast. But if your logic looks more like, as something that you might imagine in a library, like for like, const constraint of like, this type constraints, like do a bunch of abstract stuff because we have to implement it at a much higher level, it's going to get a lot slower. So that's essentially what this takes advantage of, is that it like when you create the type, it basically like compiles a bunch of JavaScript code that is like very concrete references to all the checks that you're making, that is very like engine optimization friendly. And then it actually will, in an environments that support like executing new function, like, or basically like evaled code in sort of like a safe context here, but like that's what it is. Then what it will do is it will like replace the like, I guess like standard implementations of like basically checking various type nodes with these like optimized versions that it creates in place. And that's what makes it so fast. Or at least that's part of it. But there's like an endless amount of, I've been working on optimization stuff recently also, and there's really like an endless amount of stuff you can do. I'll say like one thing that I particularly am really excited about that like you can't see in the like community's runtime benchmarks, which is what those comparisons are based off of, uh, is things like discriminated unions. So in ArkType, I mentioned, I guess at the beginning, that one of the most unique aspects of it was this like type system where it had this ability to compare types to one another and understand their relationships. Well, like part of that is that like for any given branches of a union, it could like intersect them and say like, here are all the places where I could check, and like it would tell me if I'm on branch A or branch B, which is really what a discriminated union is, right? You need like some kind of check you can make that says, am I checking this branch or like am I checking this branch? And I want to know that right away. So normally that's like tag or kind, but it could be all sorts of stuff. You could say that like a string or a number is a discriminated union because I could check at the top level like which branch I'm on. You could say like I mean, I don't actually use this kind of optimization, but you could even say something like an object with a value property where in one branch it's greater than zero and in the other branch it's less than zero. That's also a discriminated union because you could check that property and check whether it's greater than or less than zero. And the whole point of this is a couple things, but like mainly it's that you're checking a union in constant time instead of checking a union literally linearly based on the number of branches in that union. Um, because if you can just like make a couple like constant time checks and say, okay, am I on branch 1 or 4 or 77 or whatever, based on how huge your union is, like it can save you a huge amount of time if you can just skip right to that branch and then say like, okay, make these checks and is it valid? So what ArkType can do internally is like, because it has that type level understanding, it like will determine what the most efficient discriminant that it can use is, and it can even do that over like multiple rounds of discrimination. So like basically whenever you define a union, you don't have to like explicitly say like, here's the discriminant and here's my union. It will kind of like figure out what are the optimal checks that it can make to like split apart all the branches and go to the right one as quickly as possible. And so like that's the kind of thing where you won't even see that like in some of the basic like runtime validation benchmarks, but it's the kind of thing that can be super, super impactful if you're like validating complex types or unions. And you don't have to like do anything or even know that's happening externally for it to benefit you really significantly. Also in terms of error messages, because like you ever seen a really long union error message, that can be pretty awful. But it can be much better if it's like, okay, well, I figured out that you must be trying to create this branch because your kind property or whatever was foo. So like, I'm just going to give you the error messages for that branch since that seems to be what you were trying to do. and then it's like a lot easier to unpack what went wrong. So there's a lot of cool benefits there, and optimizations beyond just the sort of like that like just-in-time compilation stuff can make things a lot faster. It's also pretty gross because like I have to implement internally, like I have to implement validation like 4 different ways in order to like get all this to work. Because there's like the built-in validation that like just checks if something is allowed or not, so like returns true or false. Then there's the built-in validation that checks and like gives a detailed error message, because that's a lot less efficient. We only do it in cases where you actually fail. Then there's the like JIT optimized, like literally I had to write it in JavaScript strings, right? Like, you know, version of like, is the thing allowed or not, return true or false. And then the like, okay, JIT optimized, like let's build a, you know, helpful error message when the thing fails. So you know, it's like it was a little bit of a pain to do, and it is great that it's so much faster. But I'll level with you guys, like it is kind of a headline feature because people get like really excited about performance and whatever. But like I think compared to Zod, you know, Zod is like, oh, I'll take like, you know, 1 microsecond to do this. And ArkType is like, well, I'll do it in 10 nanoseconds or something. But like, is that really your performance bottleneck? Like, yes, it's 100 times faster, but like it was already probably fast enough that it's not going to be the number one thing that's going to screw you over. So like, I would say that type level performance is actually probably a lot more relevant based on a lot of the consulting work that I do, where like people are struggling with like Zod and TRPC or various things, like, you know, crashing their editor. So like that aspect of things is probably more likely to be a bottleneck. And like the per stuff, it's like, hey, great if you are doing something where you're, you know, validating tons and tons of data. And like, hey, maybe in some of those cases I mentioned with unions, like if you're checking complex unions, yeah, that can take a long time. And so maybe some of those optimizations will really be helpful for you. But I do think people tend to like really fixate on those metrics. And I will admit that like part of my motivation for optimizing them was that I knew that people really love them. And like I got tons of feedback on that with the first release, like how fast is it? And like everyone wants to know that stuff. But you know, for those in the know, like it's probably not actually the most impactful thing for a validation library.
Yeah, for sure. I mean, especially because like a lot of times you're validating hopefully on the outsides of your API. So like as things coming in, you're not like running it, you know, hopefully again, and like really hot loops or whatever.
Yeah. I mean, I'd say I'm like on, you know, handling like server, like JSON payloads or something, like, you know, maybe it is the case that like you're processing the same sort of data a lot. And that's like a case where it could be somewhat useful. But still, like whatever your logic you're doing internally to kind of like process it after it's been validated is pretty much guaranteed to be way less efficient than like whatever. I mean, I think Zod is like a reasonable, you know, reasonably performant for like what it's doing. And I think unfortunately, people who look at the performance benchmarks are like, Zod must be so slow. It must be like, what did he do? Like he must have written awful code. And that's not at all the reason why there's like such a big differential. It's because of this, like, and I've been in pretty close touch with Colin, and I guess I shouldn't like leak whatever he's doing for Zod 4, but he'd probably be fine. That like, I know that he's implementing some of these like, you know, just in time optimizations for Zod 4. So maybe people will have something to look forward to there once that's ready. But yeah, all said and done, like, you know, I bet like 1% of users would like really significantly benefit from this kind of optimization, and it's pretty marginal for most people.